Okay, so we're looking for the missing area and the missing side length. So how do you find area of a rectangle? Base times height or length times width, same difference. So you need the dimensions of your rectangle in order to find the area of it. Notice they're not labeled here, but they give you a bunch of other information that you can hopefully use to figure it out. Anyone have the base of the rectangle? So this is the one we're trying to find the area of. Can anyone tell me one or both of the dimensions of it? 10. So let's problem solve our way through that. That's probably this longer side for the 10. And Ryder, how'd you find that?
There's an 8 at the top. And then the tiny box at the bottom. 3 minus 5 is 2. So 2 plus 8 is 7.
Okay, perfect. So use your critical thinking skills. This is clearly a square, but even if it was just a rectangle, we know that the opposite sides are congruent. So from here to here is 8 inches. This little missing piece, again, use your critical thinking skills. If this from here to here is 5, this other smaller rectangle is 3, and that must be 2. Add them together, 8 plus 2 is 10. Now I need the other dimension so that I can find my area. So far I have that my base is 10. Anyone know what this side should be?
2.
2. And then where are we getting that?
From the small box on the right.
Small box on the right. What about it?
Like if you follow the line of the rectangle through the small box. Maybe like divided.
Okay, and that's what someone said earlier, that it looks like that is right in the halfway point of 4. But you can't assume that everything's drawn to scale. So there is another way to reason it out. It does happen to be 2. Anyone else have a different way of finding it? Jack?
On the big box, the other side is 8. So in order for the other to be on the other side.
Okay, so looking at this side that's labeled 8 and this side that's labeled 10. And maybe that's what you meant, Ryder, but I wasn't saying it at first. So yeah, so then that means from here to here, it must be 2. So then what's my area of that rectangle? You all know because now you have both the dimensions. The area for this is 20 square inches, or 20 inches. All right, good. Now the other one we are missing a side length. We do know the area of all the rectangles. And I don't have the other dimension, which would be helpful because then if I only have one unknown, then I can solve for the unknown. Look at what else that you are given. What are some side lengths that we can identify? Table 6, can you identify the side lengths of any of the other rectangles?
For the one on the very right in the bottom, is base would be 6.
Okay. So I don't know if you found that first. If you did, I'm just not seeing it. I would have found probably this side length first, and then probably led my way to over here. If my area is 60 and one of the side lengths is 12, what times 12 gives me 60? So then from there, now that I know that this side is 5, so basically from here to here is 5 also. Which basically means that from here to here is 8. Because 5 plus 3 is 8. This is the side length of 6 down there. Because 8 times 6 is 48. That's the order that I would have solved it. But yes, this is 6. I don't know if there's another way to clearly see that, but that's probably the steps you would have followed. Which then in turn helps me figure out this missing dimension. If you're not seeing it clearly, what does it have to be? Okay, let's see. I know from here to here is 12. Plus 6, so like from here to here is 18. 3 plus 11 is 14. This missing side length should be, oh, okay. This missing side length then should be 4. Everyone see that maybe? So this entire side is a total of 18 because 12 plus 6. If I subtract from 18, 11 and 3, 14, I get 4 for this side length. Now the one in question, we have all the information we need now. So if you're not seeing it clearly from, I don't know, the one rectangle they're pointing out, but you see all these other rectangles, it's probably leading you there in some way. So what times 4 will give me 36? 9. So the missing side length for figure B is 9. Questions, comments, concerns? So being a good problem solver, being able to reason your way, kind of think of it like a puzzle, is something that'll help you in this lesson. This lesson is the first of 3 parts. They're all titled Rewriting Quadratics in Factored Form. So let's get the goals real quick on that. We are going to investigate quadratic equations. Oh, wait, no, this is not the right one, sorry. This is the other one. Okay, there it is. We are going to write expressions in factored form when we are given the standard form. In last unit, we went from factored to standard. So where we like FOIL, where we double distributed, where we did the box method. We went from factored to standard in the last unit. Now we're going in the opposite direction. It's one of my favorite lessons to teach, although I kind of have to let you problem solve your way through it at first. I'll give you a few ways that you can organize your thought process of the puzzle later. But by the end of the lesson, be able to explain how the numbers in a quadratic expression in factored form relate to the equivalent expression in standard form. Be able to, when you're given them in factored form, rewrite them into standard form. You've already done that. And when given a quadratic expression in the form x squared plus bx plus c, you can rewrite it into factored form. So notice they left out the a. Well, really, they didn't leave it out. They're just saying that for this lesson, a is going to be 1. When a is not 1, the steps will be slightly different. It's just like 1 added step. But just know that for this lesson, a is 1. That's why they didn't write it, because it assumed to be 1 if it's not it. I record every day in case you didn't know that. So there it is, where it will be when I'm done recording. Puzzle piece is lesson 6. And we will take our first quiz for the unit on Friday. Make sure your notes are ready. Make sure that you ask questions. Make sure you do practice. I do have tutoring today if you'd like to come by. I have it Tuesdays now only after school. But other teachers have it basically every day of the week. Just let me know and I'll tell you on what day and time. Also, Saturday Academy is a Saturday. You don't need to be invited to Saturday Academy to come. So if you are not happy with your grade, maybe you want to go from a B to an A, even, like, we can help you. You've got to come. Like, there's nothing else that we are doing in class except for doing the learning. In May, we'll take our last unit test. we'll take our finals and then that'll be it. So if you're not happy with your grade, you gotta come to for Saturday exam. This, I do have to start pushing. Inviting you to maybe consider giving cheer a chance. We normally would have a tryout this month, but we are hiring a new head coach, so that's almost done with that hiring process. We will probably have a tryout in July. So that gives you the entire summer to work on your skills. If you want to join our band, it's linked in the slides, you won't have to scan it right now. But, it's just the band app that has all the information about summer clinics, about when tryouts are. And I can say so many great things about the program. We won state and nationals this past season, so really big accomplishments. And then especially, even if you're a boy, like, we want you to consider it. All of our boys have had about 2 years or less of experience, and they are making great strides. They have college scholarships. They have even Chase, he's only a sophomore, being reached out to by like some great colleges for their cheer program. It's very hard to get a scholarship in football, in baseball, even if you've done it your whole life, it is very difficult. But in cheer, especially if you're a male, I know that seems kind of unfair, it is, but there's a lot fewer males in cheer. And you can learn so fast. Girls, we still welcome you. There's plenty of room on all levels of our program. So consider that, work on your skills, join our band app for that information. Any questions? Okay. Anyway, moving on. Here is the first activity aside from the warm up. Yes. Yes. Okay, we've seen these before. The box method diagrams. You're gonna answer these questions about them. So first, what does this represent? What expression? That means like numbers and symbols. And then second, what does this next diagram represent? And what numbers need to go in each blank? And is there another equivalent expression still? I'll give you 3 minutes before I start asking you questions. So we can move to the answers. What does this first diagram represent? There's like 3 possible answers and I would accept. Okay, good. So here's our standard form expression that this represents. In the last unit, we called this like the box method, where each individual square inside, it's like finding the area. So like multiplying the dimensions of each individual square. And then once we did that, we combine like terms, and then it happened to usually be the X terms that we combine. Here's our standard form of it. There is another expression. Anyone know, like, when we were putting the box method together, what would have been the given expression? You know what I'm talking about? So like before we FOIL, before we did the box method, what would it have been? Right, no one? What are some other formats of quadratic expression? We have standard form, what else is there? Factor form. Based on this diagram, can you tell me what the factor form was before it was multiplied together?
So parentheses X on the two, parentheses X two.
Close. X plus 2, and then X plus 3. But yes, so this was our original problem that we would have either FOIL, double distributed, put in the box diagram, and then multiplied out. So now we should be able to fill this in because we've done it before. I'm gonna ask you for these blanks, but any questions on that? Okay, ordinarily, we would set up our box method based on how many terms we're multiplying by each other. So those are 2 term times a 2 term, our box would look something like this. And you always keep the sign that's in front of each term. So if they're all positive, then you don't really see the sign, so we don't usually write it, but then if it was negative, you make sure it was still there. Okay, now over here, we're gonna fill in these blanks. So table 9, what goes here where my mouse is? X squared, good, X times X. Table 1, what goes here where my mouse is? Good. Table 2, what goes here? And table 3, what goes here? Is it positive or negative? Positive, because we have a negative times a negative. When you multiply an even number of negative times, your answer is positive. All right, now what would be our final answer in standard form for this? Table 4, can you tell me? So now I put it all together with my final answer. For multiplying. Does the X squared have a like term? Okay. Does the negative 6X? What's its like term? And when I add them, what do I get? And then does 12 have a like term? Okay, so then this is our standard form expression of this one, once you fill it in. Table 5, can you tell me what the factor form was?
If X was 8.
Okay, X minus 6. Yes. So, Jack, I think you were maybe thinking of something else, I'm not sure. Oh, okay, good. Well, this, when I put it together as a 2-term expression, does become X minus 2. And then the other side, when I put it together as a 2-term expression, does become X minus 6. And we multiply them together. That's what that box is saying, not we do. Okay, questions on that? Yes? Glad you do it. So for the next part, you are going to use a diagram to show that each of these is equivalent. This is almost exactly like a question that is on your final, your constructed response final, except for that it would obviously be different numbers. Okay, but use a diagram to show that each pair of expressions is equivalent, kind of like we just did before. So make it, since it's something you've done before, I'm gonna freeze my screen and then show you the answers after about 3 or 4 minutes. I'll leave these up as an example. So do number 3, that's on your paper. See if you can observe any patterns. Although I will admit the patterns are less obvious than before, but we'll tie it all together.
So this is what your proof could have looked like. It said to use a diagram. So like if on your final, it says to use a diagram and you don't, I mean, I wouldn't necessarily mark you off full points, but just follow the directions. So here's what your diagrams would look like. How big you make your diagram is dependent on how many terms are in each factor. So like I have x, one term, times x plus 3. That's why it's little. And then since I multiplied and I get this, that proves it. If when I have a 2 term by a 2 term, that's where it looks like this. I show what it looks like before I combine like terms, and then when I combine like terms is how I get my final answer. Over here, they wrote it a bit weird, but hopefully you guys know that when you add a negative, that's the same thing as just subtracting. But when you make your diagram, always keep the sign that's in front of each term. So like if it's positive x, make sure it looks positive. If it's -5 and -1, make sure it looks negative. Questions on setting that up? Easy question on your final, right? Now, this isn't on your paper, so just kind of look up at the screen. I'm going to write it down somewhere you can. But it says to observe the patterns of the expressions that involve the product of two sums or two differences. So mostly like these two down here, although you can kind of see it with this one. But do you see like any patterns between the numbers? Anyone? It's a bit obscure. I know because I know what they're trying to allude to. But if you could summarize it, the constant in your expression always ends up being the what of the two numbers? Ms. Navina. Yes, no problem. Preston, and you can look at your diagram. What math did we have to do to get the 8? I need everyone to look, this is super important. What math did we do from here to get the 8? So the constant is the product of these two numbers. I don't know how to like describe those two numbers. But if you look down here, 5 is the product of these two numbers as well, isn't it? -5 times -1. How can we describe the number that's in front of the x term? What math did we do to get 6? You can look up here. How did we get 6? So it happens to also be the sum of these two numbers. Same thing down here. The sum, when we added them, -5 and -1, x is how we got -6x. So using that pattern and that observation, when you get to this activity that's on the back, and it asks you to go from standard form to factor form, I need to think of what two numbers multiply to give 12, but at the same time add to give 13. I'm saying it out loud, just think about it. Think of two numbers that multiply to give 12, that add to get 13. Multiply to 12, that adds to 13. 12 and 1. So guess what my factored form is going to be? X plus 12 times x plus 1. And you could check it. You could make your box diagram and check. Does that, when I multiply it together, give me this? And yes, it does. Let's try a different one. Let's look at one with a negative. With this one. Think of what two numbers multiply to give you this number. And at the same time, add to get you that number. So don't say it out loud yet. There's two numbers that multiply to 9, but at the same time, add to -10.
Table 7, do we know? Two numbers that multiply to 9 but add to -10. There's only a few ways you can multiply to 9. Do you want to start there? Guys, what can I multiply to get 9? Please tell me that first. And there's no way that I could possibly get -10, so it can't be that combination. How else can I multiply to get 9? Good. And since it adds to a -10 and multiplies to a +9, these would both have to be negative. So then when I write my factors in factor form, it would be x minus 1 times x minus 1. Questions on that? I know it's hard at first. I'll give you another way to organize your information that I think is easy. But try that first. Fill in all the blanks on this table. Some of them you should know how to do from the last unit. I have faith in you. I'll start by giving you 4 minutes to fill out that table on that. So first, let's knock out these first 3, and then I'll show you another way to organize your information for the rest. Table 8, what's the standard form for the first one? Okay, good, and that's a unit 6 still, so hopefully that was probably easy. If not, on the tutoring, we talk it out. Table 9, what's my factored form of x squared plus 9x? What can I multiply together to get x squared plus 9x? Good. So either you could guess and check. It does say if you get stuck, make a diagram. So since I have just 2 terms, and this is what I was given, then I'd probably start with this. And then I think, what times what gives me x squared? That. Now, since I know that it has to be x, what times x gives me 9x? So that's another way you could do it. More visual learners, knowing like area, things like that. So table 9, I'll have you try this one now. X squared minus 8x, what would it have to be for the factor form? Perfect. Questions on any of those? Once you think you know it, maybe just like at least distribute in your head, see that it gives you your original. This you should know from unit 6. However, if you follow what we observed today, if it is in a format like this, it always starts with x squared. The number in front of the x is when you add these 2 numbers. So class with 6 plus 2. So it'll be plus 8x. And then the constant is always when you multiply these 2 numbers. So what's 6 times 2? So then it'll be plus 5. But of course, you could always make your box diagram, whatever you need to do, as long as you get the right answer without cheating. We have another one like that from unit 6. So then table 1, can you tell me what the standard form of this one would be?
X squared minus 8x.
Perfect. Questions? Okay, now I told you how to solve these, but I know maybe that was confusing for some of you. Here's the way that I learned it that really helped me. And it's called either the AC method or the diamond method. They call them like a bunch of different names in that one. But say for this one, I wanted to solve it for the factored form. The way that you set up your diamond is A times C on top, make sure that's a times, not a minus, and B on the bottom. And the A, B, and C come from AX squared plus BX plus C. In this lesson, A is 1 for all of them. So you don't really have to worry about A right now. But normally it's A times C on top, so 1 times 12 is. Good, what numbers in my B position for this one? A -7, so always keep the sign that's in front of each term. And the way that it's almost like making a puzzle. The way that it works is you want to multiply to the top number. And at the same time, add to the bottom number. There's lots of ways you can multiply to get 12. And then when you incorporate negatives, there's even more ways. So think about it, two numbers that multiply to 12, but at the same time add to -7. Table 2, can you tell me what those numbers are? -4 and -3. They're the only two numbers that make it work. We know that if it multiplies to a positive, then it either has to be two negatives or two positives multiplied together. If it adds to a negative, then it definitely has to be two negatives. So the answer for this one is x minus 4 times x minus 3. Or you could reverse them, x minus 3 times x minus 4. Just another way to think about it. Questions on that? You're still doing the same thing. You're still thinking what multiplies to the top. A times B goes on the top, so 9. And what adds to the bottom. We're looking at this one now. Table 3, what multiplies to 9 but adds to 6? Multiplies to 9 but adds to 6. 3 and 3, both positive. So for this one, it's gonna be x plus 3 times x plus 3. Written in factor form. Table 4, you're on deck for this one. Wait till I draw it. So for this one, we're doing multiplying to 9, but adding to 10. What do those two numbers have to be? What two numbers multiply to 9 but add to 10? Come on, guys, gotta pay attention. You can't just tune in when you're called on. Again, I repeat, what multiplies to 9 but adds to 10? Table 4. 9 and 1. Both positive. So then the factor form for this one would have to be x plus 9 in parentheses times x plus 1 in parentheses. The sign depends on what it has to be to multiply to the top that adds to the bottom. And then write it in factor form. Table 5, you're on deck for this one. When we set up our diamond, this one's gonna be 9 on top, -6 on the bottom. What multiplies to 9 but adds to -6?
Or
-3 and -3 is correct. There's only a few numbers that multiply to 9. So like 9 times 1 is 3 and 3. And then play around with the negative so that it multiplies to the top and adds to the bottom. So this one is x minus 3 and x minus 2. Know that since these are the exact same parentheses, you could also write it like this, x minus 3 in parentheses squared. Same thing for the other one, that was exactly the same. This one. You could write it as x plus 3 in parentheses squared. Now, the last one I know was funky. It even kind of got me for a second, but it's just showing you. We are multiplying two numbers to get this. And we are adding two numbers to get the number in front of the x term. So class, what does the factor form of this have to be? You get it? Perfect. X plus m times x plus n. So notice these almost all start with X or whatever variable they will use in your problem, and then they use other letters. But the sign depends on what it had to be to multiply to this. And at the same time, add to this. Questions, comments, concerns? We'll practice that tomorrow and the next day, but that's the gist of today's lesson. Do take a look at your cool down and attempt it to really see if you've mastered this. You should be able to fill in these blanks, knowing what we just talked about. But I'll stay on this page, so this one has most of our notes. Try the cool down. Once you've tried it, take out your Chromebook, start your practice. I'll project the answer to the cool down in a minute. I mentioned that I project the answer to the cool down for those that tried it, so there it is. What you should notice is that if it's in standard form, and here's like the format for standard form, that the constant is always the product of these two numbers, and the number in front of the X is always the sum of these two numbers. So for the first one, it's the first blank is 18, the second blank is 17. And notice that this only works when A is 1. When A is something other than 1, we have an extra step. So keep that in mind, that's coming in the future. For the rest of these, I prefer the diamond method. You could do the box method or whatever way gets you the right answer without cheating. So I'm looking for two numbers that multiply to 14 but add to 9. It would have to be positive 7 and positive 2. So 7 goes in the blank because the 2 is already over there. Over here, we're looking for two numbers that multiply to 10 but add to negative 7. They both have to be negative. So negative 2 and negative 5. I don't need to put another negative here because the minus is already there. Last one, I'm looking for two numbers that multiply to 20 but add to negative 9. That's negative 4 and negative 5. Lots of ways to multiply to get 20. So first I tried like 2 and 10, but there's no possible way I couldn't play around with the negatives to get negative 9. So I explored other ways to get 20s, and it had to be 4 times 5, both negatives that make it work. Questions, comments, concerns? Okay, don't pack up till 10:21, or not 10:21, 10:29. Let me know if you have any questions.